Students, today our topic is aldehyde and ketone. Aldehyde and ketone represent a family of organic compound known as carbonyl compound with characteristic carbonyl C double bond O group. Aldehyde, this is aldehyde, this is a ketone. Aldehyde and ketone has C double bond O group, C double bond O group, in which C is attached with R. Student, today our topic is aldehyde and ketone. Aldehyde is R C double bond O H and ketone is R C double bond O R dash. Aldehyde and ketone represent a family of organic compound known as carbonyl compound with characteristic carbonyl C double bond O group. Aldehyde and ketone has C double bond O group. So this is a carbonyl compound. In a aldehyde, C carbon is attached with one R. Here R is alkyl group, and in ketone, C carbon is attached with two alkyl group R and R dash. Students, there is a common example of aldehyde and ketone. First example of aldehyde is HCHO. It is a form aldehyde. It is common as formaldehyde and it is IUPAC name is methanol. Now there is second example CH3CHO. It is acetaldehyde and it is IUPAC name is ethanol. Now there is example of ketone CH3CO. CH3 is acetone and it is IUPAC name is propane 1. Now there is another example CH3 CH2 CO. CH2 CH3 is diethyl ketone and it is IUPAC name is pentane 3 1. Students, now we are doing the method of preparation of aldehyde. First action is oxidation of primary alcohol. Here this is ethyl alcohol CH3CH2OH. When it is oxidized in the presence of acetic K2Cr2O7, it is converted into aldehyde CH3CHO acetic aldehyde plus water. Here is oxidation, so there is release hydrogen which attach with oxygen form H2O. Student, next method is dehydrogenation of primary alcohol. This is a benzoyl alcohol. In the presence of reducing copper at a temperature of 573 Kelvin, benzoyl alcohol is converted into benzaldehyde plus H2O. This is reducing the hydrogen from here which release hydrogen H2O. Students, next method is preparation from the acetic chloride. This is important reaction and its name is Rosenmann's reduction. In this, acetyl chloride plus H2O in the presence of palladium over the barium sulfate with small quantity of sulfur or quinine, it is converted into aldehyde CH3CHO plus HCl. Now second examples is from this same example, there is benzoyl chloride C6H5COCl2 plus H2 in the presence of palladium over the barium sulfate in the small quantity of sulfur plus quinine. It is converted into benzaldehyde C6H5CHO plus HCl. Students, there is important point that formaldehyde chloride cannot be reduced to give formaldehyde because it is a quite unstable at room temperature. Students, now another preparation from carboxylic acid HCOOH plus HCOOH in the presence of magnesium oxide at a temperature of 573 Kelvin. Formic acid is converted into formaldehyde HCHO plus carbon dioxide plus water. From this carbon dioxide release and from this and this water is released. Now there is a next example of benzoic acid C6H5COOH plus formic acid HCOOH. In the presence of magnesium oxide at a temperature of 573 Kelvin, it is converted into benzaldehyde C6H5CHO plus carbon dioxide plus H2O. From this CH2 carbon dioxide release and from this OH plus H water is released. Students, now the next method is preparation from alkene by the Vickers process. In this process, ethylene CH2 double bond CH2 react with aqueous solution of palladium chloride with copric chloride in the presence of H2O, which converted into acetaldehyde CH3CHO plus palladium plus 2HCl. The water is separated as H plus OH negative. Student, next method is preparation from cyanide and esters. This is Stephen's reduction. CH3C triple bond N is methyl cyanide plus 2H plus HCl plus water boiling. This gave acetaldehyde CH3CHO plus NH4Cl. The next method is preparation from the benzene. This is Cutterman's-Koch reaction. In this reaction, benzene reacts with formyl chloride HCOCl in the presence of catalyst mixture of aluminium chloride and copper chloride under the pressure of 70 degree atmospheric temperature. Benzene is converted into benzene aldehyde plus HCl. Student, next method is preparation from phenol. This is Riemer-Tiemer reaction. In this reaction, phenol react with chloroform in the presence of alkaline sodium hydroxide at the temperature of 333 Kelvin to 343 Kelvin, which gave salicylic aldehyde as major product and para-hydroxyl benzoaldehyde is minor product. Salicylic acid is also named as ortho-hydroxyl benzaldehyde, which is a major product. Friends, now we are doing the method of preparation of ketones. First reaction is from the alcohol, secondary alcohol. Isopropyl alcohol is a secondary alcohol since carbon is attached with a 2-methyl group plus oxygen oxidized in the presence of aqueous KMnO4 alkaline. It gave acetone plus H2O. This is a oxidation reaction. Students, now second reaction is from dehydrogenation of alcohol. In this reaction, isopropyl alcohol react with reducing copper at 573 Kelvin gave acetone plus H2O. Student, next example is from alkene, in which we use 2,3-dimethyl butadiene react with O3 in the presence of tetrachloride gave ozonides, which gave another product acetones. Students, next method is from benzene. This is Friedel-Crafts reaction in which benzene react with acetyl chloride in the presence of anhydrous aluminum chloride gave acetophenone plus HCl. Thanks.